Okay, so today I'm gonna be solving this daily problem. I started recording, but then OBS stopped. So my idea right now is this is like yesterday daily's problem, and my idea is just to traverse rows and columns, and first start traversing rows left to right, and then every time I see a guard, I'm gonna put the flag guards on. Oh no, let me save this. Then right. Where is it? Okay. So I'm gonna go like this from left to right first. Every time I have G, I should put the flag, like turn the flag like guard on, and every time I see a wall, I should turn it off. And every time I visit the empty cell with a guard flag turned on, I should mark this cell as like guarded, and if not, I just gonna continue like traversing it. And then when I stop doing that, on the right edge, I'll start going from right to left. And then again, initially the flag is off, and then every time it's I see the guard, I'll turn it on, and every time I see the wall, I'll turn it off. So that's it for this. So this one stay empty. The cells continue. I continue doing this. This one green, turn off. Then guard turn on. Then red means like it's guarded, and then guarded, and then wall, and then again green. And then here, again it's turned off. Green, wall like those false. And okay, so if I go back, green, wall, and turn off, but I don't switch from guarded from true to false. So initially all cells are false, so it stay cross, guarded, and then this one actually becomes like guarded. So next one, green, then wall, then guard, then I'm gonna go so guarded, and then starting from this side, guard, green, but it's already guarded, then guard, if guarded becomes true, then walls change it to false, and then okay, and then next one just gonna be green, and then back also green, and then I'll start. So I finished traversing rows, so I'll start traversing columns. So first one guard, then next one guarded, then the next one becomes guarded, next one becomes guarded, and then go back. It doesn't change anything. So the water wall, then guard, then what that, the guarded, and then back same, and then this one column, this one stays green, red, wall, green, then here, and then back, green, wall, red, green. Okay, this one green, guarded, and then guarded, and then back. This one also becomes guarded, and then this one green, wall. Okay, that stays the same, and then this one, and this one stays the same. So I have cells 1, 2, 3, 4, 5, 6, 7. Yeah, so the complexity of this one gonna be, so I go and so I visit. So I first so I have to fill up the grid, and this one is number of guards is roughly the same, but n by m. N is number of rows and m is number of columns, and then number of guards. So the initial fill up of this matrix, or like array 2D array, is n by m time complexity, and then I'm gonna go every row back and forth. So it's gonna be so the n rows and then m columns, and then I'm gonna go back and forth. So I'm gonna be 2n for the like from left to right, and then 1 for the right to left, and then I'm gonna go top to bottom, bottom to top. So it's gonna be 4n by m. So just roughly n by m time complexity. So the space complexity gonna be n of n by m also, because I need to save this matrix that's gonna have store intermediate state. So that's it. Check what's there. Okay, so this one, count unguarded. So I'll create this board, and it's gonna be like or it can be even 2D array. 2D array in Rust. So this one. Copy this one. Okay, solution 2257. Struct solution 2257. Then impl solution 2257, and this function. No, this function. Interesting. What was it showing to me? No, not right. So let's return 0, like -1, and then initially I'll create the board, and it's gonna be this one. Say int n equals. Okay, it's already m and by n. Blending m by n grid. Okay, so it's gonna be this array. Array Rust. Okay, something like that. We can create a board. It's gonna be n by m, or like m by n, and then here gonna be what? m by n, here m by n, and then let empty equals 0, let guard equals 1, let wall equals 2, let guarded equals 3, and then I'm gonna go SU size, no, okay, so vector, m n and then m. Why not? N is here. Why I cannot find it? N, I copied that. Okay. To direct. Why it's not working here? Ah, okay, I got it. Board, something like that. SU size. So board empty guard wall guarded. Okay, and then I'm gonna go for let guard in guard iter for guard in guards, and then board put board guard 0 guard 1 is equal guard. Okay, and then do the same for the walls. For wall in walls iter board guard is wall SU size, then wall1 SU size equals wall. Okay, and then I'm gonna go for I in 0 up to m. SU size, okay, for j in 0 up to n SU size, say is let's mute as is guarded mute is guarded equals false, and then if board I j is equal empty, I'm gonna go I'm gonna put if is guarded equals true. I'm gonna put board ij equals guarded. If else if it's not guard, if it's guarded, if it's called guard watches, is guard watches, if it's guard watches, if board I j equals wall, I'm gonna go is guard watches equals false, and then if board I j equals guard, then is guard watches equals true, and then what else can it be? Can be there, which is something like that. And then let's do the function. So I should do that. Let's call it fn update board let is guard watches boolean, like this boolean, and then board okay, and then is guard watches, and then I u size j u size and then bool, let's say mute reference. So, and here, if this one had true, I'm gonna go if it's empty. So let's call it like this. Why not? I cannot use a global variable size. No, looks like no. Okay. to Rust and let's call it empty hero guard, then wall, and then guarded, then state, and then that's gonna be word of empty so state, okay, no, derive clone, how to do that, derive clone, can I do this inside? No. Can I do this inside? No. Can I do this inside? Yes. Why can I do this inside here? Okay, whatever. State card, state wall, and then here if it's empty, state empty, and then board state okay, partial equality, can I do eq? Okay, something like this, and then next I wanna do this update board ij reference is guard watches, then reference board. And this user is date board solution date board. No, still no. Why? Let's do the okay. Update board should stay inside. Can I call it just update board? This no. Why? What is happening? Mute. More of mutably. Okay, and then board. Mute. Okay, now seems good. And then for j in n -1 -1 Okay, 0 to n. So if card watches equals false, and then here, and then okay, if card watches false, and then I'm gonna go solution, the same, but actually here gonna be n minus 1 minus j. SU size. SU size. Okay. And then I'm gonna do this for the every column. So j for 0 and n. Which is j I from 0 to m, and then ij, same, and then I from 0 to m, and then here gonna be m minus 1 minus I, and then here gonna be SU size, and then I'm gonna calculate the number of so I can calculate it even like while I'm doing that traversal. Every time it's empty and the cell stays empty, but and kind of exit early if it's like wall or guard. Yeah, but it might be too much. So I'll do 4 I in 0 m SU size, and 4j in 0 and SU size, same, and then let me address, then gonna be what I32, gonna be just 0, and then if board ij is equal state empty, I'm gonna do press plus equal 1, and then in the end I'm gonna return this. Something like this. So let's try it out in the simple solution. So I will have solution something like this. Let us equal. Okay, even I can call it like the solution 2257, and then I need to call this count unguarded, and then I need to push mn. For this one, I'm gonna be 4 and 6. 4, 6, and then I need to go guards and back. And here. And then the second one gonna be wolf. And this one, the same here. Look. And then the output should be 7. So I'll go let put equals, and then print a line. Then here Leetcode 2257, 5.7 test 1, and then let's goes here output. Okay, let's run it. Output 7. Okay, so let's think about what can go wrong with this problem. So can it be like 0 rows, 0 columns? Yep, it can be. And in this case, gonna be just empty. Just 0, okay. Okay, up to solution. Okay, bits 0. Memory is quite a lot. 32 milliseconds. Don't like it. Let's try out some of this C++. That's a lot. Yeah, it's a little bit better than C++ even, or like this solution with C++. What does they do here? So vector, and then fill up with minus 2s, and then okay. Can I paint this? What's interesting, if I can modify it, so like, can I do this tricks of Rust? When I can do change the contract, let mute. And here mute. Now let's see, mute here. Oh, it does it better actually. If it mute, I'm just gonna check if I can do this mute walls. It's working. Interesting. Okay, but it will not help me because guards can be like pretty sparse, and like I still need to create a board. Okay, I'm gonna stop recording.